day and welcome to another program of the day. Today we'll be discussing about panels. This panel that we'll be discussing on is an MCC panel which is used to feed jet fans. As you can see, this is the name of the panel, which is MCC B2TJF. It is used to feed number of jet fans. Okay. As you can see, on the outer part of the panel, we have three indicator lights, R, Y, B. As I did mention, it's used to indicate the healthiness of the supplies. On the side here, you see the first part that you see is for one particular jet fan, which is JF01, B2TJF01. And then it has an indication light for low speed run, low speed trip, high speed run, and high speed trip. This indicates the fan is running on low speed. This indicates the fan that is running on low speed has tripped once you see this light on. And then on the other side is the high side of the fan. Below it's low speed start. This is when you start this fan at low speed, and then this other part you start this fan at high speed. And then here is a stop push button when you want to stop the jet fan. And then on this other side you see a selector switch which has hand, off, and auto. So the hand is for manual, auto is automatic, and then the off is putting off the fan. So if I turn it to hand, therefore means I have to operate these fans or the jet fan on manual condition. Therefore means I have to press the start button in order to put on the fan either at low speed or at high speed. And then if I turn it at off, therefore means the fan will be shut off. There is no power given to the fans. If I turn to auto, it means the fan will operate automatically by the help of BMS or through the fire alarm system. Well, we'll have third-party cables that are leaving from a relay control module in order to feed or give supply to the fans for it to function in automatic condition. Okay, in the case of BMS, it will be operated from the BMS control room. And in the case of fire alarm system, it will be operated from the fire alarm control center, or probably by the use of the relay module like I mentioned. The third-party cable is going to drop inside the panel, which I will explain that. And then in the case of fire condition, that is if the fans are off, it will turn on automatically in order to push out the smoke in this room and then send it outside. I'll put it at off now. The next will be for B2TJF2, that is the number 2 jet fan. The third jet fan, the fourth jet fan, feed 6, 7, and 8, then 9 jet fans. So this panel is feeding 9 numbers of jet fans. And then like as you saw here, the low and high speed, therefore means these fans or the jet fans are it's a 2-speed control fan. So therefore means the motor will be controlled by 2-speed starter. Okay, I'll open the panel so we can see inside. Okay, inside the panel, what we'll be able to identify now will be our circuit protection. For example, now we have an incomer which is coming and then hit on the MCCB. This is an MCCB which is rated 100 amps, which will feed the whole entire panel. So the MCCB, and then on the side here we have an aluminum bus bar. On this other side, we have also an aluminum bus bar. So this both bus bar, we have the first one which is for neutral, as you can see here, and so the incoming supply comes, the neutral will be terminated here, and then on the other side will be the earth bus bar. As you can see, this is the earth indication. Then the earth conductor will be terminated on the other side. As you can see, termination is already done. And then down here, this is the chamber which has bus bars which connects the three faces, arrow, Y, B. So the arrow face, Y face, and the B face, which is the blue face, will be connected to the bus bar, and then the bus bar now connects to the other parts of the panel. On the other side, we have cartridge fuses. As you can see, I will open one of them from Schneider Electric. This is one of them. This is a cartridge fuse which is being connected in the panel as well. So these are just protective fuses. And then below we have a transformer which has an input of 230 volt at the primary side of the transformer, and then at the secondary it steps down the voltage to 24 volts DC. Below we have isolator switches which receive power from a downstream of the MCCB model case circuit breaker, and then it feeds the isolator switches, and then below now from the isolator switches output it goes and then feeds the different contactors, as you can see below. So once I turn on, this is off, I turn on the isolator switch, it powers the contactor. The contactor will be powered. Once it's powered, we know how contactors function because these are two-speed motors. So this KM1, KM2 represent one motor. This is a two-speed starter, as I mentioned previously. So from here it goes and then feeds the motor from the output. So the two contactors will have the two different runs which are going to the motor. So we have motor 1, motor 2, motor 3, motor 4. On the other side, which I will open, and then we will have to discuss about that as well. Below we have single pole relays which are powered with 230 volt AC. So this 230 volt AC will energize the coil of the single pole relays in order for the auxiliary contacts to function normally or properly. Below also we have single pole relays as well, which are used for the control part of this panel. And then on this side we have, these are the push buttons which are used to control the motors, as we discussed outside. Okay, I'll open the other side as well. On the other side now, below we have cartridge fuses which we saw in the other side, and then below we have contactors, 3-pole contactors. Below again we have single pole relays which are powered with the same 230 volts supply. And then above here now we have connectors which are indicating a particular motor. So therefore means this is motor 1, motor 2, motor 3, motor 4, motor 5, motor 6, 7, 8, and 9, as we saw outside on the indication light, which are 9 different jet fans feeding from this MCC. We have also here the bus bar, which we have connected our head conductors as well for the individual runs of cable coming from the jet fans. So these are the two runs now. Motor 1 we have first run, and then the second run which is connected to the motor with the jet fan. So the first will come to the high speed, the low speed side, and then the second comes to the high speed side. As you can see, below we have the high speed is 1.10 kilowatts, and then the low speed is 0.23 kilowatts. So the high speed will connect the cable to the high speed, and then the low speed will connect the other cable. So based on what you see on the load schedule, calculations have been done based on the high speed, what will be the size of cable to be used for the high speed. Usually for the high speed, since it has a high capacity of power, so the cross-sectional area of the cable also is usually high. So if you see a high cross-sectional area and a low cross-sectional area which are leaving from one particular motor, therefore means the high speed will be the highest cross-sectional area of the cable. As you can see, everything is being connected, and then top here we have bonding which is done as well. So we have bonding which is connected to the head link of the gland, the copper gland. As you can see, we've done the looping all together and then bring it to the head bar, so everything is bonded. as you can see. Why do we bond this? We bond this so that it will be connected to the armoring part of the cable, because this is an armor cable which have strips of armor inside the cable. So therefore means when we do this bonding, we automatically add the armoring part of the cable as well. Thank you very much for the lessons. If there is any critics or anything to be added to this video, you just comment below so we can make adjustments in the next video. Thank you.